For today's 5-minute episode, I thought I would spend a little bit of time talking about independent and dependent probability. And let's do this through one example. Suppose a bowl contains 6 red tokens and 6 blue tokens, and you want to find the probability of drawing a red, a blue, and a red in that order. So I'm just going to put 1, 2, 3, 5, 6, and then 1, 2, 3, 4, 5, 6. So we have 6 red tokens, we have 6 blue tokens, and we want to find the probability of drawing a red, a blue, and another red in that order. And first we want to do it with replacement, meaning if I draw one token, after I draw that token, I put it back. And then I draw my second token, I put it back, and then I draw my third token. So at this point, we do it just like it's going to be the probability of red times the probability of blue. I mean, not forget another parentheses, times the probability of the red again. Now, how many do you have? Because remember, probability is the amount you're looking for over the total amount. How many do you have in total? Well, you've got 12 in total. How many red tokens are there? Well, there's 6 red tokens. Well, when you put that back, how many blue tokens are there? Well, there's 6 blue tokens, and the total number of tokens has not changed. And then you have 6 red tokens, and the total number has not changed. Now, one thing that might make it easier for everybody, instead of doing 6 times 6 times 6, then 12 over 12 times 12 times 12, is just to simplify this. What's 6 halves simplified? Or I kind of just said it, 6 twelfths. That's the same thing as 1 half times 1 half times 1 half. And that's 1, because 1 times 1 times 1 is 1. And 2 times 2 times 2, 2 cubed, is 8. So your probability of drawing a red, a blue, and then a red is equal to 1/8, meaning if you did this 8 times, you'd probably get a red, a blue, and a red once. Now let's consider without replacement. This is the one that is dependent. Each drawing is going to be slightly different than the previous one because your numbers are changing over time. The operation is still probability of red times the probability of the blue times the probability of the red again. But let's look at this. When you start off, how many reds do you have? Well, alright, you have 6. Well, how many total? 12. Now this is where it gets different. You now have 6 blues, right? But how many tokens do you have in total? It's not 12 anymore, because you're not replacing them. It's just 11. This is what we call the probability of B, given the fact that A already exists. It's the probability of B given the fact that A already exists. Let me write this a little bit better. B given the fact that A exists. Probability of B given A. Now, how many red tokens do you have for the third one? There are 5 because it has changed. But luckily, we're now down to only 10 tokens left. So if I were to rewrite this, it's definitely 1/2 times, I can't simplify 6/11ths, so that just stays 6/11ths, and 1/2 again. So I got pretty lucky on the last one. Now this 1 times 6 times 1, that's the same thing as 6. Now 2 times 11 is 22, times 2 again is 44. If I were to simplify this down, I can divide both sides, the top and the bottom, by 3. And actually not by 3, by 2. And 44 divided by 2 is obviously 22. Now if you want to consider these, alright, 1/8, 3 out of 22, they look pretty different. But if I were to really unsimplify this one, multiply both the top and the bottom by 3, that's the same thing as 3 over 24. Now, if you look at this, you're more likely to get this one than you are to get this one. So the probability of drawing a red, a blue, and another red without replacement is actually higher than if it were just independent. But once again, this is the difference between independent and dependent probability. Independent, your numbers for something simple like this are not going to change. But for dependent, your numbers change with each consecutive probability. Anyways, that's going to be it for today. Ladies and gentlemen, have yourself a good weekend.